at triangles, we're going to look at the types of triangles there are, and we can classify them. So here's a word, classify, right? Classify means to sort, right? To put them in certain categories, classify. So here's some vocabulary words. We're talking about degrees. Right? You can classify triangles by their degrees. And we're not talking about temperature, right? You can't say, well, that triangle is hot or cold, but by its angle. And we'll talk more about that. So let's erase this and go to town, right? All right, so let's create a triangle, right? Oh, wait a minute, that's not a triangle. Or is it? Well, what if I cut it in half? Now I got two triangles, right? So one thing, a rectangle can make two triangles, or a square. So when we look at triangles, we can, again, we're going to classify them by their degrees, or we can classify them by the length of their sides. So let's do that first. We'll talk about the length of their sides, and we'll make our first one. So if I draw a triangle here, and a triangle has three sides, obviously, and let's say I put a hash mark on each side like that. Well, that hash mark means that all the sides are equal because they all have the same hash mark. And when all three sides of a rectangle, of a triangle, are equal, then it's an equilateral. That's an easy one to remember. Equilateral. All equal. Okay. So then I'll draw another one over here. Right? And I'll put a hash mark there, and maybe one over there. Now you notice two sides are equal because they have the same hash mark, but this one has a different hash mark. So only two sides are equal here. So when two sides are equal, it's called isosceles. So I'll write it over here. Sounds like a Greek hero, right? Isosceles. All right, there you go, isosceles. And that's how some students remember it, because they think of Hercules, isosceles, Hercules. That's two people. That's one way of remembering it. So again, isosceles, two sides are equal, equilateral, all of them are equal. Right? And there's one more. We'll bring it down here. Right? And I can put a hash mark there, there. Notice that none of the sides are equal because they all have different hash marks. So if none of them are equal, it's called scalene. All right. Those are our three triangles based on their sides. Scalene is mean. That's how some people remember it. Scalene is mean, has no friends. Therefore, none of the sides are equal. So isosceles, two sides are equal. Equilateral, all of them are equal. All right, I'll draw one. You tell me what type it is. Erase time. There we go. So if I draw this triangle, and what do you think? What type of triangle is that? Right, isosceles, excellent. Right, sounds like Hercules, two people, two sides are equal. Isosceles, great. All right. And one more for now. What about that one? Scalene, right? Scalene's mean. No friends. No sides are equal. Scalene. So what we did is we talked about equilateral, we talked about isosceles, and we talked about scalene. So rewind the tape if you didn't understand that. So now, our next way we can classify, remember the word classify, triangles is by their degrees. Not their temperature, but their angles. So just remember, when we have an angle, right, like let's say like that, and there's the vertex, there's a certain amount of degree to this angle, how wide it opens, right? And the greater it opens, the greater its degree. So this could be a 45 degree, and that's what they put for the degree sign, 45 degrees. But if it was steeper, well, maybe that's 50 degrees. And do you know what you need to see if you're right? What do you need? What tool do you think you need for degrees? Well, you need a protractor, right? A protractor, and we'll use protractors in another video. We're actually going to create degrees and create triangles. So anyway, the steeper the angle is, the more its degree is, right? We have 45, 50. Sometimes you can guess. And what you can use is if you have one that's straight, like an L, and it has this little box in it, that's 90 degrees. 90 degrees is an L. So make an L, you have 90 degrees. And a 90 degrees angle is also called a right angle. So this is a right angle, which is 90 degrees. And anything lower than that, as if it collapses, think of this as a chair, right? So if you're in a chair like this, and you fold back the seat, well, that's going to be lower than 90, right? Like we said, this could be 45. And we can even make one smaller. Look at that, it's even lower. Maybe that's 30, and so forth. So as you're sitting in your chair and then you want to bring it up, you're going to have, there you go, 90 degrees. And if you go back more, you'll have even higher degrees. Like we can have an angle right here. And see that thing I just made, that little kind of semicircle? That represents the angle, like I did here. Maybe this is 110 degrees. So again, as we're leaning our chair back, right? The degrees get bigger, right? They become greater. Now, it doesn't have to be this way. It doesn't have to be going from left to right. Degrees can also go the other way, right? Right? You can have a 90-degree angle, and it could be a backward L, right? As long as it has that box, it's 90 degrees. And what's missing? What do you think's missing? That degree symbol, that little, looks like an exponent, right? And again, like over here, we can maybe that's 40 degrees, right? We could do another one. Whoa, what's that, right? Maybe that's 20. 20 degrees. Now, a straight line. Let's say you take your chair and you fold it all the way back and you make a little day bed, whatever, you want to take a little nap. A straight line is 180 degrees. And you can make even greater angles too, but we're going to talk about that in another video. Let's just concentrate on the triangles. So, let's get rid of that 90 degree here. Let's make a triangle. Boom, there's your triangle. It's a 90-degree triangle, right? So if it's a 90-degree triangle, it's called a right triangle. There's our right triangle. There's the first one, our right triangle. It's 90 degrees. And we know it's 90 degrees because it has a box. By the way, you can't be sure it's 90 degrees, 100% sure, unless it has that box there, and that you use your protractor to check. Like we could have something like this, right? And there's no box. And you say, well, it looks like a 90 degree. But if there's no box, this could be actually 89 or 88. So we really want that box there to say that it is a right triangle. Okay. Now, we talked about a right triangle, but it's also an acute triangle. So what's an acute triangle? Well, let's create an acute triangle. We have all these marks here. This is for the degrees. And if all the marks were lower than 90 degrees, anything that's lower than 90 degrees is acute. So again, here's 90 degrees. This angle right here would be acute. That's acute. It's cute, right? It looks cute. This is 90. Or a straight angle. A right angle, that is. Not a straight angle, right angle. So we have a right angle, an acute angle, and then one that's greater than 90 degrees is an obtuse angle. So we can apply these with triangles too. Very important now. I'm going to create a star right here. It's very important to know that all triangles, if you add all the degrees of a triangle, it will come out to 180 degrees. You can't have a triangle that's greater than 180 or less than 180. It has to be exactly 180. All right? So we made our right angle before, our right triangle before. Let's draw that again. All right, so here's our right triangle, and here's our other angles. Let's say I make that 45. Well, you know this was 90 already, because the box says that's 90. And remember, I told you, all triangles have to equal 180. So what's missing? What's this degree? 90 plus 45 plus what is 180? 45, right? 45, 45, and 90 is 180. Right? So here's our right triangle that has a 90 degree and a 45, 45. Now, it doesn't have to be 45, 45. Right? It just depends on the slant of the angle, right? This could be, again, we know that's 90. And maybe this is 60. Then what does that have to be? If that's 60 and that's 90, what's missing now? 30, right? Because 60 and 30 is 90, and 90 and 90 is 180. So I think we know our right triangles, right? Because they have to have a right angle. Okay. Now I mentioned acute. We can have an acute angle, right? So let's say, and in an acute angle, every angle has to be less than 90 degrees. Every one. So if I made this 80, and I made this 30, what's missing? What's missing? What degree is missing? All right, so right here I have an obtuse triangle. Again, we talked about the acute, where every angle is less than 90 degrees. We talked about a right triangle, where there is one 90 degree. But with obtuse, we have one angle that's greater than 90. So let's say this is 130. So again, one angle has to be greater than 90 in an obtuse. And this could be 30. So we have 130 and 30. What do you think's missing? Again, all triangles have to equal 180, right? So 20 degrees is missing. And there's an obtuse triangle. Okay, so we did triangles. Here are the types. We did it with degrees, right? The acute, the obtuse, and the right. Again, the right has a 90-degree angle. The obtuse has one angle that's greater than 90. The acute has all angles are less than 90. And then we also did it with sides. We did isosceles, where everything except one is equal. Equilateral, they're all equal. And scalene, none of them. So this is with length, this is the length, and this is the degree. And we can also put them all together. We can put them all together. For example, this one right here. This is an obtuse angle, and it's also scalene. It's obtuse because right here we see one angle is greater than 90 degrees, right? And it's scalene because none of the lengths are the same. So you can mix them together. That's an obtuse scalene. All right, and then let's put together an acute equilateral. Why don't we do that? So we have so we have all the sides are going to be the same. And if they're all the same, that means all their angles are the same. So if this was 60, then this is 60, and that's 60. Here we do. All the angles are the same. All the lengths are the same. So this is an acute, right up here, an acute equilateral. And will it fit? Just fits, right? And one more. I'll do one more. This one is a right isosceles. It's isosceles because you know two of the sides are the same. And it's a right angle because of this box. So that's a right isosceles. Okay, so we classified triangles today. Great job.